Okie doke, so I'm going to take a crack at this bad boy here. So how we doing, ladies and gentlemen? Hope you guys are staying busy, staying safe. Feels like it's been a hot minute since I've seen you guys, so just make sure you guys are taking care of your family, doing what you guys are supposed to do, and make sure you're keeping up with the work, okay, because that is important. So, that being said, this is going to be my first crack at a video here. We'll see how it turns out. Be nice. So, this is a quiz you guys took right before we left school. Okay. Hold on a second. My cat's coming. All right, get down. So, here we go. So, our object here is to find the missing value to the nearest hundredth if necessary. Okay? Which it is necessary because both of these answers do come out in decimal form. So, we look at this one. Okay, as we can see, the angle in question here, okay, is not given to us. Okay, but we can label these other spots here. So this is our opposite, this is our adjacent, and this is always our hypotenuse because it is located directly, is the side located directly across from the 90-degree angle. Okay, so that's how you can always tell which side is which. Okay, you got your opposite here, it's opposite the angle, adjacent is always the one closest, and hypotenuse is always with the the opposite side of the right angle. So, in this one here, okay, you're going to want to use tan in order to solve this. So we don't know what theta is. We're going to go 13 over 43, opposite over adjacent, okay? And then in order to find this answer, we're going to take the inverse of tan on both sides. So you're left with theta on the left, and on the right, okay, you get the inverse tan. So make sure you're in degree mode. Okay, that's important. So make sure you're in degree mode first off. So when you take the inverse tan of 13 over 43, you should have gotten 16.821, and it says rounded to the nearest hundredth. So theta is equal to 16.82 degrees. And that should have been your answer to number 1. Okay, number 2, to actually give us theta, in this case it's 33. I'm just going to label our sides here. So this is our hypotenuse because it's located directly across from our right angle. This one is our opposite because it's directly across from the angle that they gave us. And this one's going to be our adjacent. So you have to think, okay, which one involves opposite and hypotenuse? Okay, and so that would be some old hippie. Okay, so they give us sine, or they give us theta, I mean. So we go sine of 33 degrees is equal to 16 over x. We don't know what the hypotenuse leg is. All right, so in order to solve this, you got to multiply both sides by x. So you get x times the sine of 33 degrees is equal to 16. Divide both sides by the sine of 33 degrees. You're left with x equals 16 over the sine of 33 degrees. Make sure you're in degree mode. So you're going to go 16 divided by the sine. Whoops, not inverse sine, sorry. 16 divided by the sine of 33 degrees. And you should get 29.377. And we're going to round it up to the nearest hundredth, which is 29.38. Okay, so that's what you guys should have gotten for your answer there. All right, and so let's move on here. So the next question says, find your reference angle for the following. Okay, so what you want to look at, all right, is what quadrant this thing falls in. Okay, in order to find that reference angle, give me just a second. Okay, So, 98 degrees, okay, just like the band. It's going to come right out somewhere in this direction. So this is the second quadrant. So we want to go by our nearest horizontal axes. Okay. 180 or 360. So we're going to take 98. And we're going to subtract that from 180. You get an answer of 82. So the reference angle is 82, which means we're talking about this angle over here and the other quadrant, somewhere in that direction. Okay? So reference angle should have been 82. So for this one, the next one we're 212, which means we're somewhere just past this horizontal axis here. But we still want to go by the nearest one. Okay? So we're going to go 212 minus 180 because we don't want any negative angle measures. So 212 minus 180, and you get 32 degrees. So the reference angle for 212 degrees is 32 degrees. Okay, the next one says, write the following as functions, of a positive acute angle. Okay? So, here we go. Let me set up a couple axes here. Oh, you guys are jealous, so I get to make these nice straight lines. Okay. You can use a ruler. So, 170, all right, is just before this axis here. So it's somewhere in quadrant 2, all right? Which means this one, when all said and done, is going to have to be negative, because if it's in the second quadrant, that means our sine is positive, not our cosine. So let's find our reference angle first. So again, because we're in quadrant 2, our closest horizontal axis is 180. So we go 180 minus 170 is equal to 10. All right, so the reference angle is 10. So you're going to go cosine. Let me get a different color here. So you go cosine of 10. And because cosine is negative in the second quadrant, you put a negative sign there. Let's go to the next one. Okay, 295, which means we're somewhere over in this direction. Okay, we're in the third or fourth quadrant. Okay, which means our cosine is positive and our sine is going to be negative. All right, so in this case, when we finish writing our answer, it should be a negative answer. So, give myself some room here. All right. So I find our reference angle. Because we're in this quadrant right here, our closest horizontal axis is 360 degrees. So we're going to go 360 minus 295 equals 65 degrees. So, our answer here, all right, sine of 65 degrees, and because we're in the fourth quadrant, sine is negative. And then our last one, right, tan of 190, so that means we are just past 180 degrees, but our closest horizontal axis, again, is 180 degrees, so we don't want negative numbers, so it's, 190 minus 180, which is 10. So our answer is tan of 10 degrees. So here we have a positive acute angle. And because we are in the third quadrant, tan is positive. So we leave that as is. Okay? So these angles should be equal, or this I'm sorry, this figure right here should be the same answer as this one down here. Okay, so anyway, that is number 6, 7, and 8. So number 9, 10, 11, 12, 13, 14. Okay? So these ones are ones you should have been trying to memorize. Okay? So I'm just going to kind of go through and put in what the positive acute angle is for all these. So the cosine, or anytime you see square root 2 over 2 for sine or cosine, we know that's 45 degrees. Okay? Sine of, when sine is 1/2, okay, that means we have, all right, get down. Okay, sorry, my cat keeps jumping up on the table here. All right, that means our reference angle is 30 degrees, okay? This one here, tan, square root 3 over 3, again 30 degrees. Cosine is 1. Well, that one's not too bad. All right, that one's just 0 and 360, so I'll just put that answer right there. Square root 3 over 2, that's 60 degrees, and when tan is undefined, okay, don't forget tan is sine over cosine. So for something to be undefined, that means we need 0 in the denominator. So that means, okay, this point is 1, 0, this is 0, 1, this is -1, 0, and this is 0, -1. Okay, so the only time when we have 0 in the denominator is when we're at this angle and this angle. Okay, when we get 1 and -1. Okay, so that degree measure is 90 and 270. Okay, so let's go through the rest of them now. All right, so let's do our all students talk constantly. And then we have to think, okay, when is cosine positive? So that is here and here. So find all possible angles. Our first one is just going to be 45 degrees. And our next one, to find what this angle is, we're going to subtract from 360, 45 degrees. So 360 minus 45 is 315. Okay? So where we have a positive square root 2 over 2 is at those two degree measures. All right, let's look at the next one. All right. So again, I'm going to do my all students talk constantly. Okay, I'm going to do it for this one too. Might as well get ahead of the game. And this one down here. Okay, so all students talk constantly. All students talk constantly. Students talk constantly. Okay, so we're looking for when sine is negative. Okay, so that would be this one here and this one here. So that means this degree measure. All right, we're going to go 30 degrees from our horizontal axes. So it's going to be 210. And then it's also negative over on this side here. So we're going to go 30 degrees from our horizontal axes. And so 360 minus 30 is 330 degrees. So that is when we will have a negative 1/2 for those 2 degree measures. So the sine of 210 degrees and the sine of 330 degrees is negative 1/2. Okay, so for the next one, we're looking for when tan is negative. Okay, so that means it's going to be here and here. Right, so again, our reference angle is 30 degrees. So we're going to go 30 degrees back from our horizontal axis. So it's going to be 150 degrees. We're going to go 30 degrees back from here. So again, 330 degrees is used. Okay, so there's our answers for the first three. Okay, we already got these two down here. So we just have this last one right here. All right, so we're looking for when sine is negative. So it's going to be here and here. We're going 60 degrees. So 60 degrees from that horizontal axis. So it's 180 plus 60 is 240 degrees. And then we're going 60 degrees back from that horizontal axis. Okay, which is 300. Okay, and that's how you find the answers to those. So my advice is to first find your reference angle, set up your all students talk constantly, and just start drawing in your angle measures. All right. So again, we always go from the horizontal axes. All right. So when you measure going into each quarter, you're measuring from these two spots. Okay? All right. So let's go down to determine in which quadrant an angle with the following characteristics could be found. Now you're probably getting tired of drawing this graph, but it's worth your while, especially with these problems right here. Okay? So, all students talk constantly, all students talk constantly, all students talk constantly. Okay? So here we're looking for when sine is positive and when tan is negative. Okay, so let's look for sine is positive. Sine is positive in both of those. And tan is negative here and here. So as you can see, it all lines up with quadrant 2. Let's go to the next one. We're looking for when sine is positive. So that's here and here. And when secant, which is just 1 over cosine, is negative. So we're looking for when cosine is negative. And cosine is negative here and here. So again, we are in quadrant 2. And for the last one, looking for 1 over tan, and we want that to be negative. So tan is negative here and here. And we're looking for where cosine is negative, and cosine is negative here and here. So again, quadrant 2, racking up the points in all three of these problems. Okay. And for our last one, it says the terminal side of theta in standard position contains the point 7, negative 24. Find the exact values of the 6 trigonometric functions of theta. Okay? So let me draw my axes here. I would suggest using a ruler if you don't have this tool. Makes life a little easier. All right. Not a great graph. Let me extend this part down here just a little bit more. Good enough. Okay. All right. So we're over 7. So we're going to go over about 7. It's not going to be exact. So we're going to the right 7. Man, too much coffee today. My hands are shaking. Woo! Okay. And then now we're going to negative 24. So we're somewhere down here. All right. So we'll just, it's not going to be exact. Now I better make it a little more right triangle looking. And then there is that. Okay? So here's our right triangle. This is 24. Okay, so we still have to find what this side is. So if you haven't thought about how to find that side already, you should be thinking Pythagorean and their theorem, okay, which is a squared plus b squared equals c squared. And we got to remember c is always our hypotenuse, right? Because it's directly across from our right angle. So I'm going to put this as A, this is B, so I'm going to go 7 squared plus 24 squared equals C squared. Add those two up, you'll get 625 equals C squared. Take the square root, and you get a nice number of 25 for the value of x. All right, and this is what we call also a Pythagorean triple. Okay, which means you get nice numbers for A, B, and C. All right, you get all whole. I'm sorry, yeah, you get nice whole numbers. All right, for Pythagorean triples. So anyway, so now we found the third side. And so find the exact values of the 6 trigonometric functions of theta. Okay, which means we're looking for sine theta, cosine of theta, tan of theta. I'm just going to write it on the other side. We're looking for the cosecant of theta, secant of theta, and the cotangent of theta. All right. So you just got to remember this is 1 over sine, this is 1 over cosine, and this is 1 over tangent. Okay? And so we'll just do the same. So sum, also too, this is theta. So let's label our sides here. So this is our adjacent, this is our hypotenuse, and this is our opposite. Okay? Let me highlight that in red so you guys can see which one is which. Alright, so some old hippie caught another hippie tripping on acid. Okay. And so opposite over hypotenuse is 24 over 25. Adjacent over hypotenuse is 7 over 25. And opposite over adjacent is 24 over 7. Now we got to remember we're in quadrant 4, which means, this in orange, all students talk constantly, so the only thing that is positive here is our cosine. So we have to make sure that this is negative and that this is negative. Okay? Alright. And so the last part of this problem, all we have to do is just switch these, or do the reciprocal of tan, cosine, and sine. Alright, so the reciprocal of tan is negative 7 over 24. Secant of theta, which is just going to be 25 over 7, but it stays positive. And 1 over sine is negative 25 over 24. Or, I'm sorry, cosecant of theta, which is 1 over sine. All right? And so there's the answers for those. And there's the answers for those. Okay? So I'll be grading you guys' quizzes today. I'm just kind of testing out the waters as far as like videos go, making sure that this works okay for you guys. So obviously I can't send back your guys' quiz, but this should give you a general idea on how you did. Okay? So be expecting more videos as the week trails on. All right, Ms. Hellier will be supplying your guys' videos. I'll be doing Algebra 1 and Geometry. So, but be expecting to find all the videos in the same place. They'll be on my YouTube channel under Eric KM. Which, if you're already watching this video, I'm assuming you found it. So, anyway, so stay posted, you guys. Keep checking your emails. All right, I know OneNote and all that stuff isn't working great, but you know we didn't really have a great design in place. So just stay tight, do the snail, or stick with the emails, YouTube channel, and when things start to get a little more clear, good things we can use, applications, stuff like that, we'll keep you posted. So just hang tight, you guys, and have a good